The very first thing you should check is the answer itself. So for instance, on number 14, the answer itself is quadrant 1 and 3. If you only put quadrant 1 in a colored pen, put quadrant 3. If you only put quadrant 3 in a colored pen, put quadrant 1. First things first, grade the answer. Every now and then I have students that are like, ooh, I want to grade the whole thing and grade my work first. Well, grade the answer first. If it's wrong, put a line, put the right answer, because I don't always spend enough time having you look at the answers to get down all the work. And number 2, remember, this work is kind of like the Calc chat work in that, number 1, it's not always totally right. Number 2, sometimes there are big gaps. And number 3, it's not always the way I would have wanted you to do it. So yes, look at the explanation if there's time, if you miss something. Look at the work if there's time, if you miss something to check your work. But first things first, grade the answer, okay? Really quickly, no pencils should be out, no pencils should be moving, no pencils should even be accessible because that's cheating, okay? All right, so number 8, correct answer, -12, 0. Number 14, pause. I know, we're doing a lot of logistics. It's our first homework. If someone missed number 8, how many of you guys right now could tell me what number 8's problem was without looking at the book? Close, except you got them switched. So yours would have been a different point. Some of you guys are kind of like, oh, it's on an axis and it's something. Okay, we kind of get it. We kind of got it. Like 3 or 4 of you, but I had a lot of blank stares at first. If we're going over homework questions, it's really hard for your brain. Let's say we were down and this had like 30 different problems in homework. We've been doing it over 3 different days, and someone missed a problem, and they were trying to figure out what went wrong. Okay. It's not bad to always have your book and to always have your book open to the assignment and to always be able to compare. It's not bad to do it that way. It's just kind of tedious, and not everyone has that at their beck and call. They're not going to necessarily bring their book every day and have it open every day. And it does take more work than just having a quick summary of directions for every section of homework and a statement of the problem before actually putting the answer in every homework. Now, I didn't tell you how to format homework because I had you guys just do it the way you normally would. And for most of you, on number, what did we say, number 8, all you have is what Calc chat has or what the answer key has. But from here on out, I don't just want -12, 0. And that wouldn't be proper formatting. What I want is for you guys at the beginning of every section, every separate section in each homework exercise, I want you to put a quick little 1 to 2 to 5 word summary of the directions for each section, not for each problem. That's annoying and that's just wasting time. And a quick little summary of what the problem is. So here we are. Some of you guys were trying to tell me this. Do I want you to write finding the coordinates of a point in gray and then in black in exercises 7 and 8? No, that's dumb and that's tedious and that's a waste of your time and my time grading. But how can you summarize this real quick, real short, right before you start number 7? Find point. Find coordinates. Perfect. Find coordinates, find the point. Find the coordinates of the point. Some of you will write every single word because that's just your personality. Go for it, but you don't have to. Find the point, find the coordinates. How could you take number 7 and summarize it? Maybe in some other classes you've learned that if you can take content and if you can summarize it, it shows a deeper level of understanding. And if you've ever missed a problem on a math test because you didn't read it well enough, maybe you're understanding why I'm asking this. 3 left, good? 4 up. The one we were talking about was number 8. On the x, 12 left of y. On the x, 12 left of y. Do you see how short that is? It's short, it's sweet, and if you're grading and you mark something wrong, you're like, oh, what'd I do? Oh, let me get the book out. Oh, what page was it? Oh, let me turn that. Oh, number. And I'm already like on the second page of us grading, and you still have no idea what went wrong in the original one. But if you have a quick little summary, oh, find the coordinates. Oh, I put positive 12 when it was 12 left. Okay, I should have just put. It's going to help you grade a little faster, and it's going to help our homework questions a little faster. So starting in homework number 2, and from here on out to the rest of the year, quick little summaries of directions, quick little summaries of problems. And if you were doing like number 5 or 6, and if you had to write out each of these, if you plug something in incorrectly when we're grading, hopefully you'll be able to see like, oh, I put -3 +6. Well, that was dumb. I read it wrong. It should have been a -6. And there are going to be times, all of us, myself included, where we read something wrong, we plug something wrong in, and the more we can not necessarily slow ourselves down to a snail or a turtle's pace, but just slow ourselves down enough to make fewer mistakes, the better our grade will be. Does that kind of make sense? Okay, so starting on homework number 2, any questions on what I mean by summarize directions and write problems? Okay, I know it's weird, I know it's different, but I really think it's important. And I'm preparing you for tests where if you read the question wrong, or if you miss a little detail, it could just make the whole thing go a different direction than you want, okay? Okay. Let's come back. Thank you, thank you, thank you. Number 14, quadrants 1 or 3. Number 44, you guys hopefully have already been able to check. Number 54, there are 2 separate answers. The answer is not 0, 0. 2 separate answers. To the first question, the x will always be 0. I apologize. The y will always be 0 if you're on the x-axis. And then the second question, the x will always be 0 if you're on the y-axis. The x will always be 0 if you're on the y. 58, there are 4 answers. A was supposed to match with 2, B was supposed to match with 3, C was supposed to match with 4, and D was supposed to match with 1. And just to start off our homework questions, let's start with that I'm pretty sure most of you have a question on. How many of you got a little stuck in some way, shape, or form on 58? Just 4? Really? Oh, but then you figured it out? Okay. But at least we have 4 people, so that's a question, right? That's valid. Let's go look at number 58 real quick. It was weird. Honors didn't like it, but if you guys didn't mind it, well, go team. There is a typo. Some of you, you already see the typo. You saw it change. Someone was really nice to you in a year before because I told them to be, and in a pen marked it out and showed the right one. But others of you, if someone did not do that in your book, if you can pay super careful attention, and then when you get back to your book, go fix it, next year would really appreciate it, okay? Here we go, number 58. What might have thrown a few people off when the point is labeled x sub 0, y sub 0, but the point is in the second quadrant? What's true about, everyone can answer, what's true about any point in the second quadrant? Negative x and positive y. Why isn't this working? Mrs. Christensen was trying to help me yesterday and was doing all this stuff to my computer, but I think she did something I didn't want her to. Let's try again. Okay, it's okay. I have another way of doing it. I'm just a little bummed, but we'll survive. Okay. Can we see it all? Yeah, but let me scroll down a little bit. The second quadrant x is negative, x is positive, right? So some of you that are more abstract, that's totally enough information to go from there. But for others of you that are more concrete, you're like, I like having numbers. It's confusing when I have like notation. Maybe it would help you to make like a little pretend point and be like, maybe that's the point. -1, 2, or -2, 3, or -3, 4. Maybe you can make like a little pretend point and be like, I think it's about this. Because if you make a pretend point and you do these different like patterns, then you should be able to look at the new pretend point and know at least what quadrant it is. And if you guys notice, they're all in different quadrants. Okay, so checking out this point, whether you're thinking it's a negative and a positive number, a negative x, positive y, or whether you're thinking of like an actual concrete example of what it could be. When you guys came down here to letter A and it said, hey, x sub naught, y sub naught, well, wouldn't it just be the exact same place? But what's the problem with all the answer choices? They're all in different places. Now this one's in quadrant. Some of you guys can't match, but the problem is the y seemingly a little bit shorter? Guess what? That was the type. If your book didn't have it, I apologize. Some student didn't mark it out a previous year. So if you guys do have a pen and your book did not change it, you could change it now. We're not going to change it to what it should be. We're going to do process of elimination, figure out what graph was supposed to match there, even though you already saw the answer. And then we'll make the proper statement. So let's move on to letter B. Okay. If you multiply a negative times a negative, what would you get for x, whether you're doing the concrete or the abstract? Positive. And then if y stays the same, well, I'm going to have a positive and a positive. And the x should be a little bit further because it got doubled. So what quadrant? And a little bit further sure looks like number 3 to me. You guys agree? The only thing that changed, the x was still the same as the original, aka negative. The x is still negative, but the y, what happened? Yeah, you can think like a vertical shrink. It got cut in half, and so if it got cut in half, doesn't that make a lot more sense with this guy? The exact same quadrant, x is still negative, y is still positive, but not up as high. That's what matches with number 4. And then what happens here? The x changes sign and the y changes sign. So instead of a negative x, what's it going to be now? And then instead of the y being positive, the y is now going to be negative. So if I have a positive x and a negative y, what quadrant? Only properly matches with number 1. So which one has not been used yet? No? Oh, true. A, but which graph hasn't been used yet? So how do I get in the the third quadrant? What kinds of points are in the third quadrant, guys? And so the x can stay the same, but what has to happen to the y? Do you guys see it? The x has to stay the same sign, but the y has to flip. And the way to flip a sign is a negative. So that was the correction that should have been there. That's the proper way or the proper problem to match with graph number 2. The x needed to stay the same. The y needed to flip, aka x sub naught negative y sub naught. So for those of you guys that had that corrected in your books, it was probably a little bit easier. For those of you that didn't, it would have been quite a bit trickier, especially if you didn't remember that I said there was a typo yesterday. But that's why the answers are what they are as far as 2, then 3, then 4, then 1. Okay, other questions in homework, whether evens or odds, now's the time. Well, that was easy. Ready, set, and go. Let's put away the homework. Let's go ahead and grab out our notes. If for any reason, by me saying right now that was easy and stopping homework questions, do you think in my head every single time I'm going to be like, psh, this class could ace a quiz? No. Some of you are quiet. Some of you guys are still figuring out what to ask, what not to ask. You don't want to look foolish, even though I say as a teacher, no question is a foolish one. I know, you still have your peers. It gets hard sometimes. If we ever don't answer questions, or I don't answer it in a way that makes sense to you, what can you do? Yeah, come after school. If you're an athlete and you have like an athletic study hall, period 7 for some reason, come in during there. It's my free period. I can probably answer a question. If I can't, I'll let you know. During lunchtime, you can check with me after class. Will you be here during lunch? You can pop in. All of those are options to get your personal question answered. Sound good? You guys are so quiet. You just stare at me. If in your mind you're like, yeah, sure, whatever, give me one of these and then life is better. Is that cool? There you go. Thanks. Otherwise, I'm just like, I have no idea if they're even listening. Are they awake? Are they sleeping with their eyes open? I don't know you guys that well. Anyway, here we go. Section 1.2. You guys already started it. We're not going to get all the way through. And how can you tell that from our backboard? A, it says start, and B, homework's not due until Friday. But we will get most of the way through. Graphs of equations. There's your title, but you guys should have already gotten it. Sorry it wasn't there earlier. When you start on new homework, just like new notes, make sure it's on a new page. And one quick thing, I didn't even think to draw your attention to it. In your homework spirals, when you guys do the assignment details, I don't know what I was thinking yesterday. I never put the homework number in the heading. You guys could put it over here, you guys could put it over there. For the TA and for me, it's going to make our lives so much better if you put the homework number. So if you don't mind just adding number 1 to last night's assignment, number 2, number 3, number 4. I don't know what I was thinking. I'm sorry I forgot when we did our first initial. But please put the homework number, section, page and then the numbers themselves. Sorry for that. Okay, the section isn't crazy hard. It's just we did a lot of logistics. We graded our first homework. We talked about colored pens versus pencils and CalcChat and Google Classroom. So we're going to go as far as we can. We're going to go far enough that you can start homework, just probably not far enough that you can finish it. Okay? So in my class, it's very, 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 very rare that you have no homework. Usually, the homework is to start or to finish. Does that make sense? I know, some of you are like, well, you do you. Hopefully you grow in wisdom. But homework is tonight to start. Does that sound good? Okay. Section 1.2. Vocab word, solution. Vocab word, solution point. The point AB is going to be a solution to an equation when plugging in results in you might think you can fill in the blank, but first, nope. You might think you can fill in the blank, but first, let's do the example. So good idea of filling it in, but first let's do the example. How can we show that this point is, they're telling me it is, it's a fact, is a solution? What's one way of doing it? Plug it in, yeah. Plug it in, you're going to plug into the Y spot, and you're going to plug into the X spot. Whenever you see variables in an equation, you need to think about inputs and outputs. The variables are just holding space. You can plug in something small to that space. You can plug in something big. You can plug in something with one term or multiple terms, fractions or non-fractions. So I always put parentheses around my variables. It just makes everything safe and saves a lot of woodland creatures. Not woodland creatures, but animals we don't really talk about. Y gets plugged into the Y spot. The X gets plugged into the X spot. PEMDAS tells me to multiply, then to subtract. And guys, does 4 equal 7 minus 3? Yeah. And so since this statement is true, the point is a solution. So if the point was, got it. Solutions aren't super complicated, but we are getting some of our basics down. So then from that, let's go ahead and talk about graphs. That is the section title, right? Graphs of equations. So graphs of equations are collections of solution points. That's the snazzy way of what a graph really is. It's the whole collection of all the different possible solutions to a particular equation. But before we get into all the clues with sketching graphs, and we're just going to do a few today, like intercepts and symmetry, and the intercepts finding zeros. We're just going to do a few clues today. But before we even get to the clues, let's go back to the beginning. Algebra 1, before you knew what a quadratic or a parabola or a cubic function was, before you knew the difference between polynomials, binomials, trinomials, monomials, before you even learned y equals mx plus b, and point slope form and standard form of lines, how'd you sketch graphs? Yeah, you would make a table. You would make a table. And usually tables are like vertically oriented, at least in Algebra 1. You have the x's, you have the y's. Maybe you and then plug in and show your work as you go down. As you went higher in math, you probably did more mental math with those sorts of things, sometimes making mistakes, sometimes getting it right. And this is good and all, except if you're doing homework in your homework spiral, has anyone ever been annoyed by something that would take multiple lines like that but still be really small? Maybe not. But it's going to start to be a lot more strategic to start making horizontal tables. You don't see vertical tables as much as you go higher. Not that they won't ever appear, but horizontal tables are a little nicer, and the reason why is because they can just take up like 2 lines instead of taking up 4 or 5 or 6 lines. And let's speak about that really quickly. Some of you like to do like columns of homework instead of rows of homework. Do you guys know what I'm talking about? You like to do homework and you're like, oh, there's all this blank space. And you're like, yay! And start doing more homework over here. And next thing you know, like there's no rhyme or reason. You just have like all these different numbers. And some of you go like this way and some of you go that way. And then if you do decide to do 2 columns, can you just make it super nice and neat? And can you just fold your paper? Make a nice little and fit everything in the nice 2 columns. Is that okay? Other than, Jordan, go ahead.
If I do it like all on one side and then the other half, or like 3/4 is all my work.
Oh, that's okay. That's you kind of going like this. Does that make sense? But all what work? Is it your scratch space?
Like that's like that, and then this is
It's okay, except, let me talk about test quiz real quick. We have time, we're just starting 1.2. On a test, on a quiz, if you use scratch paper and you don't number anything and it's God knows what order, no, this is the reason why. I won't give you partial credit for anything on the page. Why? I'm not going to go around looking for number 2 in all of that when there's no number 2. So it might be a good idea.
I used to like if I was number 2, I would like put a number 2 by that section, but then like it just got
Just in the future, when it's like a formal assignment, you're going to want like a formal assignment, paper, just for you to keep in mind. And so it might be good for you to start doing it now, where like for each problem you're keeping the work, or have that be scratch, but have it like be scratch for this, scratch for that. Like just have the scratch work spaced out. That way, at least you're keeping it in some sort of rhyme and reason, so that if, well, number one, if you're correcting your homework, you can actually find the work that went with the problem that you might have missed. You know what I mean? It's just going to make things a lot easier on you and on me, and I can give you more points, which is good. But good to bring that up. But if you are using, but even with you, Jordan, if you are using that, just fold the paper real quick, just a little bit, and then you're like, oh, sweet, I'll keep it. It's nice. All right, here we go. Sorry, horizontal tables are going to be a lot nicer. But here's what I want to let you know. Even though you're in pre-calculus, even though you've made it through Algebra 2, and you've learned like slope-intercept forms of lines, and you've learned some things to do with parabolas, that's a little bit harder than just like shifting it down or right or left. And you've, even though you've learned a lot, doesn't mean that you can't go back to a table. If you can't use your graphing calculator and you're trying to figure out a picture of a graph, you can always, last resort, but you can always go back here and be like, well, let's plug in. And in Algebra 2, we plugged in things like -2 and -1 and 0, 1. Isn't that what all Algebra 1 kids do? At least at the beginning. Or -4, -2, 0, 2, 4. Why would that not be very strategic with the math experience that you have for an example like this? It's a square root. And if you go plugging in 1, 0, or -1, or all of those are imaginary, that's not going to give me anything. So be strategic in how you do the table. Don't just go back to Algebra 1 and just plug in a few points and say, well, it didn't work, there must be nothing. Keep going and say, wait, hold on, I've gotten more math training than this. What about 3 and 4 and 5? There are tons of points there. Or -3, -4, -5. So be strategic how your points. But anyway, I would say probably not that one. You guys should know how to do lines, especially after we review it real fast. Parabolas, okay, all right. He was kind of hard. He's a little bit hard. Why is he a little hard?
Because
Yeah. You have the x squared and you have an x term. If it was just -3, couldn't you do parabola down 3?
Yeah.
Right? But, I mean, you could factor. You could, okay. But that's kind of going to page 10 or the next page of notes. So hold on. We'll get back to him in a second. But he might be a good one for a table. But this one definitely is a good one for a table. Because you're like, I don't even know what that is. Some of you might realize it's a linear function for certain values of x, but it doesn't exist for others. But he's complicated. I would definitely do a table on that guy if I were you. Functions are going to be tables because they're just more complicated than we're used to. Even calculus had this whole assignment, this whole sheet of functions, like all messed up, all transformed, all weird. And even after having 20 basic graphs that they should have memorized, some of them still needed to make tables because they were like, I don't know what that one looks like. Let's just make a table. So tables aren't totally bad. But we don't have to stop with tables because you guys have learned a lot. And so the very, very beginning of graph clues were intercepts. Let's review those real quick. And it was even a homework problem last night. I think it was number 54, where it talked about what kinds of points or what's true about a point that hits the x-axis or hits the y-axis. I think that was 54. So from those problems in homework, or even just from your math knowledge and skills, what's true about any point that's on the x-axis? Intercept, intersect. Any point on the, or intersecting. Hasn't gone up, hasn't gone down. Y's haven't gone positive or negative. Y's are just 0. So you can go ahead and find it by setting y equal to 0 and solving for x. Sometimes there's more than one. So I'm going to put, even though I'm going to show you an example as to how or why, x-intercepts are also called zeros. That's what that function in your calculator was doing in the second trace menu number 2, right? Zeros. So if it just says find the zeros of the function, it specifically is talking about the x-intercepts. But when you're solving by hand algebraically, I need you to attach zeros, x-intercepts with factoring. Now technically it's only if you have polynomials. But a lot of you just like adding things to the other side and dividing and trying to do all this snazzy playing around with the x's to try to get them by themselves and forget that factoring is a super valid, super necessary skill. And we'll see that down here. Y-intercepts, what's different? If you're hitting the y-axis, you haven't gone right, you haven't gone left. The x's are just... It is up and down, sorry. But what I meant was the x value hasn't gone positive, you haven't gone to the right. X value hasn't gone negative, all the x's are 0. Good. Set all the x's equal to 0. Solve for y. This one's great to solve for. He's nice. Except, do you guys want to see one of the most common silly mistakes the calculus kids made on their summer review packet, which was mostly pre-cal review? That has to do with that. I asked them something similar to, I won't do the exact problem, but something similar to, let's see, y equals 7x times the square root of x minus 1. I asked them for the intercepts. Basic, right? Algebra 1 stuff. And when they went to go solve for the y-intercept, the easy one, and they went to go plug that x was 0, guess what a lot of them did? They got there. They even got here. But guess what a lot of them said the answer was? Now, first of all, that's imaginary. So maybe their problem was quite that tricky. Let's pretend there was a little positive. Because if it was imaginary, they would have known that doesn't exist. They would say DNE. So let's just, because their example did exist. But why is this horribly wrong? 0 times anything is 0. Yeah, I know. They were too focused on the hard and the above and the other stuff they had to study, and they weren't paying attention, and so a lot of them, I think at least 10 out of 40, made that mistake. That's crazy. But your brain can do funny things when you're not paying attention. Anyway, is that right? No. What's the right answer? Yep. Coming back. So, example. What if we were supposed to do this guy? It's crazy. Sometimes it's the basic stuff that kills you. Or that messes you up. There's a life lesson in that somewhere, but let's keep going. Sometimes it's the stuff you don't even expect. All right, this one's kind of easy. You have a graph. Hopefully it's easy. I don't mean to assume anything. Hopefully it's easy. Because if you're looking at the graph of y equals x cubed minus 4x, you're supposed to find the x-intercepts and the y-intercepts. Hopefully you can just look at it and say, well, which points are the points where it intersects the x-axis? And what do you guys see? X is equal to -2 or and +2 and 0. Good. I have 3 different x-intercepts. You could just give me the x values, because by definition, the x-intercepts are when y is 0. You could also give me the points of the intercepts. That would be valid. Right? The y-intercept would just be x equals 0 or y equals 0? Because by definition, x is already 0. That doesn't help me. You could just put the point 0, 0. So there's one point that's shared. That's both the x and the y-intercept, right? But the y-intercept is easy, algebraically speaking, because the y-intercept we would just plug in, and hopefully, unless your brain was doing something funny, hopefully you would know 0 cubed minus 4 times 0 is just 0, right? But the algebra gets a little tricky if you weren't to have the graph and you were supposed to find the x-intercepts or the zeros of the function. So let me make a quick point. If you were to set y equal to 0, okay, just a few of you, maybe up to half, would say, yay, let's add the 4x. It's not bad. It's not awful. It's not impossible to get any part of the right answer by adding the 4x. You just won't get all of the right answer. And if you don't get all of the right answer, it's technically wrong, right? So if you were to add the 4x, it's not horrible, except your next step would be either to divide the x, which is what it should be, and you would only get plus or minus 2, and you would miss the 0 altogether, or you would just get stuck and not know where to go from there. Instead, go back to what I wrote just a second ago, and Joe already said it, was to factor. So let's pause. If you know how to factor, go ahead and show me how to factor. And if you are like, not quite sure my brain would have thought that, maybe you should pay attention as I go ahead and finish the problem to show why the answer is negative 2, 0, 2 from the equation. So with factoring, finding the common factor, there's an x in both. What's left is x squared minus 4. Maybe, hopefully, you recognize x squared minus 4 to be a difference of squares. It's one of those where the outer and the inner canceled because they matched, but the signs were opposite. And then if you guys remember from way back when, or even from all your work in factoring in Algebra 2, once you have factors, technically there are 3 of them equal to 0. How do we find all the zeros? Set each one equal to 0. So x equals 0? Yes, that's right. X plus 2 equals 0 minus the 2, and x minus 2 equals 0 plus the 2. Only with factoring would you be able to find all 3. Unless you already noticed, oh, 0 minus 0 works. Good, now add the 4x. But very few students actually do that on a consistent basis. Okay? So that's why I put that keyword of factoring up above, because when you don't factor, answers go missing. When you start trying to do it other ways, you just get messed up, and things start ending up lost / not in the answer / getting it wrong for you. I think this page was pretty much, oh, hey, look, go team. Let's skip here. That was a warm-up for tomorrow since we're not grading homework tomorrow. So we'll come back to that one tomorrow. But for right now, don't worry, don't leave any space in your notes. Just keep going. Warm-ups don't go in your notes. They go somewhere else. We'll talk about it then when it comes up. The last thing we'll just introduce is symmetry. I want you guys to go ahead and just set this up. Skip 2 lines for me. When you're setting up this page. You do the whole page so you guys can see it. We're not going to totally get through symmetry today. But we can have it set up for tomorrow. Tonight in homework, I think, just from an honors kid that was working on the section yesterday, I think symmetry shows up around the 30s, somewhere in there. So you should be able to get a good start in homework as far as up through the 20s, maybe even into the 30s a bit. And if you're one of those independent students that's able to go farther than what you see in class using the examples in the section, that's just better for you as far as tomorrow night. And you can come into class already having looked at some of the ideas and just making sure that your understanding is good. So maybe some of you will go farther than that, which is awesome. But maybe some of you get scared when you get into a section that you haven't seen an example like. If so, get up through the 20s and then just pause. I think I already took roll. I was just double checking that we're all good. Nice. All right, kiddos, we're going down to the wire, right? We have 30 seconds or so. So, homework tonight is to, there you go. Homework tonight is to start. It's okay, I'm training you. Homework tonight is to start. If you guys have any questions about Google Classroom, about grades that are on RenWeb, I think it's mostly forms right now. I do have your graphing calculator quizzes graded. So if you want to come see the grade, you definitely can. I'm not going to pass it back though because Salma still needs to take it. So we'll get it back to you guys once she finishes catching up.
Do we have to like
See you all later.
Today's like what we wrote and submitted to Google Classroom?
No, because the deadline is not until